Hello, I am Jay Healy, the head instructor of Lee's Science Academy. This channel delivers basic knowledge of natural sciences logically and systematically, which is good to have before starting your major studies in college. Also, it systematically delivers the mathematics necessary for studying science. Up until the last session, we created natural numbers and examined the 4 basic operations of natural numbers and their operation rules. Today, we will study the process of expanding natural numbers to create integers. Here is the main content of today's lecture. We will look at the core details regarding the process of creating natural numbers. This content was studied in the lecture Creation of Natural Numbers, which I have posted as a recommended lecture in the description box below, so please watch it if you are interested. We will create the number 0 and examine the concepts that 0 represents. We will also study the creation of negative numbers and their functions. And after completing the integers, we will study what properties integers possess. Here is the system of real numbers that we will complete in the future. Integers within the system of real numbers consist of natural numbers, 0, and negative numbers. Since we created natural numbers last time, today we will complete the integers by creating 0 and negative integers. Through the process of abstraction, we created natural numbers purely through thoughts in our minds. Let's create the natural number 1, which is the most important in creating natural numbers. In step 1 of the abstraction process, we found a single common property from various given objects and created the concept of 1. In step 2, we gave that concept the name 1. And in step 3, we completed the number by creating the symbol to express that name, the number 1. Afterwards, we complete the natural numbers by creating numbers larger than 1. The method of creating larger numbers is by adding objects one by one to the previous number, creating a new concept and a new number. This process continues endlessly. By adding 1 to 1, we made 2. By adding 1 to 2, we made 3. By adding 1 to 3, we made 4. By adding 1 to 4, we made 5. And then by continuously creating numbers like 6, 7, 8, 9, we created the entire set of natural numbers. Following the creation of natural numbers, let's learn about the creation of 0. It is said that 0 was created by ancient Indians. You know where India is, right? Here is a map. Here is South Korea, and past Singapore, the inverted triangle-shaped country is India. It's a country in the Indian Ocean with a population of over 1.3 billion and a large landmass. The people of India could express well using natural numbers when there were apples and bananas on a plate. However, by progressing with an abstraction process on the state of having nothing on a plate, they came to think of a new concept, decided to name it 0, and expressed it with the symbol Hindu-Arabic numeral 0. 0 is the abstraction of the concept of a state where there is nothing on a plate. Its name is 0, and its symbol is the Hindu-Arabic numeral 0. Now the number 0 has been created. Let's find out how the newly created 0 is used and its functions. Since 0 is an abstraction of the concept of a state where there is nothing, the symbol for 0 expresses the concepts of a state of nil, nothing, and blank. As mathematics developed, the concept of 0 expanded, and it also came to express the concept of the result of an action indicating nothing remains as a result of an operation. So when we take away 3 from a plate that has 3, nothing remains, so we can write it as 0. In the decimal numeral system, when changing place values like 100, it also expresses a state where no numbers remain in the lower places. 0 also expresses the reference point in a number line or coordinate system, which we will study later. Following the creation of natural numbers and 0, it is now time to create negative numbers. A certain person borrowed 5 apples from a friend and put them on a plate. That person expressed the number of apples on the plate as 5 according to the concept of natural numbers, but they realized something was missing. Although they possessed the apples they had, since they were borrowed, there was a lacking aspect to call them their own possession. So although the person could express their state of possession with the natural number 5, they wanted to reflect the concept of having borrowed into the number, which is step 1 of the abstraction process. They named it a negative number, as a number different from natural numbers. This is step 2 of the abstraction process. Then, they expressed that concept as a symbol by attaching a minus sign, like the subtraction operation symbol, to the number. This is step 3 of the abstraction process. For the abstraction process of numbers, please refer to the recommended lecture, Creation of Natural Numbers, below. Whether the minus sign expresses a borrowed state or the action of an operation, subtraction, is easily distinguishable depending on the context. In this way, humans use the negative number -5 to clearly express the fact that, while they have 5, it is something borrowed and possessed. -5 expresses the fact that although one has 5, it is a debt. A negative number is a symbol expressing debt. Through this process, humans came to create negative numbers. With negative numbers created, when we want to clearly distinguish and express natural numbers from negative numbers, we use them like +5 by attaching a positive sign in front of the natural number. Let's learn about the function of the newly created negative numbers. A negative number is a natural number with a negative sign attached to it. According to the concept used when making negative numbers, a negative number has the function of expressing a debt equal to that number, not an asset. The concept of debt is expanded to express a state of deficiency or lack. When distributing lunch boxes to students, if there is a shortage of 3, the deficient state is expressed with the number -3. It also expresses a state where the result of an operation action is short. When subtracting 6 from a plate containing 5, the shortage of 1 is expressed as -1, so 5 minus 6 is expressed as -1. It means it is short by 1. By creating negative numbers, you can understand that the subtraction operation has become a closed operation in the set of integers. You remember that in the set of natural numbers, the subtraction operation was an open operation, right? Strictly speaking, the minus sign of a negative number is also used as a means of expression to indicate the opposite direction to the reference direction when expressing direction. In the compass rows below, if we express the left as positive, then the negative direction becomes the right, and if we express the upward direction as negative, then positive expresses the downward direction. Conversely, if we express the left as negative, then we express the right as positive, and if we express the upward direction as positive, then we express the downward direction as negative. In the future, you will learn about vectors as numbers with direction, and the fact that the minus sign indicates direction is well shown in vectors. In vectors, a vector with a minus sign indicates that its direction is opposite to a vector without a sign. And the reference direction can be freely determined as needed, because you only need to indicate the direction. You understood that the minus sign indicates direction, right? With the natural numbers, 0, and negative numbers we have created so far, we can complete the integers. In mathematics, natural numbers, 0, and negative numbers together are called integers. Natural numbers are also called positive integers, and negative numbers are called negative integers. The composition of integers is visible at a glance. Let's examine the properties of integers to see what overall properties the integers, completed by creating 0 and negative numbers, possess. You understand that natural numbers have the functions of counting numbers, ordinal numbers, and nominal numbers, right? Integers, as clearly revealed in the process of making them, are discrete numbers where the numbers are not continuous but spaced apart. Although we haven't learned about the number line yet, if we display it on a number line within the scope we know, it is displayed discontinuously like the picture below. There are numbers between integers as well, but such numbers do not belong to integers and become rational or irrational numbers. We will study rational and irrational numbers next time. What is important for us studying science is to hear in advance that when a physical quantity is expressed as a discrete number in physics, that physical quantity is said to be quantized. So far, we have examined the initial process of creating the concept of numbers through abstraction, and then the process of making integers by inventing 0 and negative numbers. We also completed the system of integers consisting of positive numbers, 0, and negative numbers, and examined the properties and functions possessed by 0 and negative numbers. Furthermore, we looked into the fact that integers have discreteness rather than continuity. Following integers, we should complete the real numbers by making fractions and irrational numbers. But since it is necessary to first study the basics of Euclidean geometry before completing the real numbers, we will take a detour for a moment. Next time, we will examine the definitions and axioms section in Euclidean geometry. This concludes today's lecture. Thank you.